Hi everybody, I just wanted to quickly shoot a very quick video just showing you guys the next bit of the power supply. I haven't discussed the microcontroller interface board in much detail to date, and I just wanted to take you guys through that. If we have a look at, there we are, there's our interface board. There you can see there's our Arduino with its inputs and outputs. You'll notice that I have 3 analog channels free, but apart from that everything's used up. I've also got an I2C IO extender with 8 more bits, or 8 more IO pins, and they're also all used up. And there's our ESP8266s. As I showed you last time, just the 2 board configurations. These 2 are put right in parallel, right across from each other, so it effectively just makes space for either one of the 2 configurations that you can get your hands on. There's a 3-volt voltage reference. It feeds off the 5-volt line and provides a hopefully solid 3-volt output to that. It's just some I2C pull-ups over there. Right, so let's go through the board interconnect first. I showed you guys this last time. 5 volt, 3.3 volt ground, current limit, SN, SCL for I2C, our 3 volt voltage reference, then a 3.3 volt alert for that regulator, and a 5 volt alert for that regulator. We can set those up to either notify me when it's over current, over power, etc., under voltage and that kind of thing. Then there's our AV sense input, which is our main input from the channel 1 voltage sense. This is where we measure the actual voltage being applied as opposed to what we're telling it to. There's AV sense 2 for our second channel, and there's current limit 2 for our second channel. And these connectors go right through all the connectors, all the various modules. So if you wanted to extend it by putting something else in its way, and it might require I2C input, or any one of these other pins, you can extend the power supply to whatever you need. Right, so getting to our I2C LCD connector, you'll notice that I've got the bare minimum connections that are happening here: 3.3 volt, ground, I2C and reset. And those will feed through to our I2C PCB LCD mount that I'll show you in a moment. There's our simple I2C IO extender. I've binded the address because there's only a single one of them, and you'll see the various outputs here. So let's go through those quickly. So mode switch 1 and current sense encoder A and current sense encoder B go to this connector over here, and that connects our rotary encoder, which has an integrated push button on that. And there's our second rotary encoder for voltage that connects into there. And you'll see the various buttons and LEDs I've got here now. So here's an output enable LED, output enable switch. So when you press the button, the output actually gets turned on, so you can preset and then output the voltage. A current limit LED for channel 1, a 5 volt alert LED, 3.3 volt alert LED, output enable LED 2 for channel 2, current limit for channel 2, output enable switch for channel 2. Then I've got the reset switch, which you might have seen on the front panel. There's our temperature monitor, as well as our fan output. This will be pulse width modulated to keep the noise factor down. Let's have a look at what that translated into as a PCB. So you'll notice that we've still got the same form factor. There's our binding our standoffs for the Arduino, which flow all the way through all various modules to form a really rigid construction. There's our 3 front binding standoffs. There'd be plastic standoffs coming to these, as the module below would be need conductive standoffs to push the bulk power into the controller, into the analog controller board. There's our I2C LCD connector, our temperature monitor, our fan, and there's our current set and our voltage set inputs. The 3-volt voltage reference is all the way to the side to keep things, just keep it out of everything's way. I don't think I would need to put any cutouts in the board for that kind of thing, but experimentation will tell. Yeah, so that's the end of that. Let me quickly show you the LCD interface. So on the LCD, the specific part I'm using, the DOG M204-A, has a 44-pin output, and you'll see that 7 of the pins require some capacitance, 1 microfarad caps. The LEDs, the backlight, requires some drop resistors just to keep those at a nice constant 10 milliamp. And there's our input, which is the only outputs or inputs from this board. And I've made a little PCB actually mounting of the LCD. The LCD will fit straight onto the back of this and get mounted with simple standoffs. Let's have a look at what that looks like in 3D. I've at the moment put in place just a standard 3-channel version, so the 0 to 30 volt and the 3 and the 5 volt channels on this one. There's other options up there, as I've shown you before. You'll notice that in the chassis I'm only using those channels, as this specific mask for the 3-channel option will cover up the rest of the binding post holes and button holes and things you don't need. Right, so let's have a quick look at our LCD mounting board. You'll notice that everything, the pins will get soldered on there. There's our capacitors, there's our drop resistors, and they go and get mounted straight onto the chassis like that. Similar with a press button switches. There's our reset button. There's our rotary encoders as our output enable button. So that's all I wanted to show you today, just a quick short video. Just a reminder that I'm still looking for some participants. If you're in South Africa, let me know if you want to be part of the group build for the initial prototype of this power supply. Let me know in the YouTube comments or or on Twitter or anywhere else you need, or you can find contacting me. There's some contact information afterwards on the last shot of the video. Let me know if you're interested, and we might get going with the initial prototypes very soon. That's all I have for you guys today. Let me know if you enjoyed the video. Comments welcome, feedback welcome. Yeah, let me know. Until next time, cheers.